Welcome to another video on my ESP32 right here. Internet of Things device which you have to enable, but also with general general purpose input output GPIO, I2C, SPI, CAN bus, pulses modulation, and so on. In my case, I started all my experiments with adding an LED and then expanding with a buzzer, 7-segment display, actually 7 LEDs, an attempt to get an event microphone attached, but that had some issues and a deeper understanding on how this works, so I had it disconnected. So maybe later. LDR, light dependent resistor, LCD display, keypad, and a servomotor, SD90. Programmed in the Arduino IDE environment, things work nicely. And via that environment, I program in random access memory, which means that when I remove the cable either on this side or on the computer side, everything is gone usually. What I haven't used yet is Ethernet network, Bluetooth, CAN bus, etc. Keypad has been a failure so far. Something either in my programming or with the keypad itself, it just doesn't work. Then I want to use several other things and trying the ESP IDF toolchain, which means also programming in C, like AVR, C in the Arduino environment, but very different. And that led last time to a not so good result with the motors. This is a fischertechnik motor. Both are controlled by pulses modulation, but a nice result with the LED. So with the probes attached to the oscilloscope, let's see whatever happens. First again, I want to do the Arduino IDE to check if everything still works. Everything except that one. And then go on with programming via the IDF. So let's go to the software environment and see what happens then. Software environment. Arduino IDE, camera for the oscilloscope, ESP IDF code, command line interface, and another one. Almost as important, I have, before I do anything, claim ownership of the USB interface. And that has to be 2 in this case, because everything is now connected, or the whole stuff is connected through that one. So this is the IDF going out now. Tools, yeah, ESP IDF, and this is correct. So let's upload, see how things work out. Go. And then here something with oh, look at that. One motor works. Oh, which reminds me, when I first connected in preparation, this motor gave a little movement. And now also a little movement. But as you can see, oh, and now I know why it doesn't work. Now it does work. One wire was out. Right here, one wire was out. So now they are working. And then it would be very nice if I... yeah, right. Okay. And right, now you see something, more or less, that way. This is better. So, 7 segment displays works. Buzzer audibly works. This one works as well, although not really convincingly, but yes, it does work. And everything else works. Let me get the show monitor. And yes, look at that. Right now everything works. And let me change the time. I need to adjust the timing. Alright. Now, a strange thing here is that without the fischertechnik motor, without this motor, I have a very different pulse width response. And now it goes nicely, but it's very shaky. But let's keep it that way, it works. So you have pulse width modulation, voltage, LED, which is this LED, which doesn't make sense right now, by the way. Now it should make sense. Yep. And it does make sense. It does not make sense because I get a voltage here while the LED doesn't shine. So that's a bit weird. And here is the LDR, light dependent resistor. Which for some reason doesn't do. Yeah, by all means, go on. Oh, that's strange. Everything comes suddenly to a halt. Anyway, that's the proof that everything works. So now further with the IDF. Let's start with actually ending the serial monitor. Then, yeah, that's a nice one. How to make sure that everything stops? Well, just disconnect the power. Oscilloscope has stopped. Well, signals anyway. Waiting a bit. Everything should be nice now. Testing. And LCD seems to be blank. That will be good. Serial monitor. Yeah, that is good. Good result. So I'm going to repeat claiming ownership. Once again, serial monitor. It should stay blank, which it does. Very good. So that means that I am going to go here. Now I've been thinking, with this stuff I have to use flash. Flash can only be made used so many times. That is why the preference is to use random access memory, which I'm using with the Arduino IDE. I haven't found a way to not make flash but make random access memory. If there is, I would like to find it. Not yet though. This is in the IDF toolchain my last way to do it. So I added GPIO output port 5, pin 5, which is the LED, and I say alright, that is pin select for output. Then right here I have to do an IO config and run it. So what next? Well, why does this camera go sideways? So that would be the LED. The buzzer, yeah, that would be a very nerving experience, because the beeper is just a beeper and it goes every time. So a nicer idea is to use one of these things, one of these LEDs, and one option is of course to use 15. GPIO 15. As an output. That could be nice, so let's just do that. And this is output, so I make another one. And I make it 15. And I have to add one here. Oh wait, I make a small mistake now, but I will correct it. Because this will have to be 1. Alright, that's one thing. this is all right, I think. Yeah. So then I can set, alright, let's make this one and do it again. Is that all that I have to do? Yes, because I only add one output. And I will very soon find out if this is indeed correct. But I assume so. So, writing it and make flash. And I can also use make flash monitor. Then I flash it and use the monitor at the same time. And maybe, just maybe, the motors will start to work. Go. And there's something else. Oh, right. That is something that is beyond me, because time and again it does this, and on the other hand it says it just ignores it and does work. So let's do it again. No, same thing. So this is strange. Why would it do that? Well, what I can do, of course, is just remove it and then have no motor at all. Right. I will just forget about the motor in this case. So that would also mean that I'm going to remove this entire stuff. Alright. No errors. Just go. What is now? Now's the question, why does it do this? Okay, this is a warning. So I don't really have to pay attention to it. It says flashing binaries. Could not open port. Oh, again. I will open the port. It says can't open the port. Resource busy. Then I will uncheck this one. Now it's okay. I check another one. Use that one. Yeah, okay, so now it's no longer used. Go. And then it works. So I do wonder why this is happening anyway. So this is flashing, which isn't it? And this one is burning. So this means that this one and this one works. I just want it flashing. I have disabled the motors. Let me re-enable the motors. See if that is working out okay. Make flash. It's writing. So it was indeed a USB 2. That is not quite correct. Now they are blinking, but the motors aren't doing anything. So this is one thing. The thing that I want to do as well, and that gives a dilemma. I want to test everything, but not in Flash, and I want to test it in this way and not with the Arduino, which is a completely different way of programming. So yeah, what to do and how to do it, because each time I write in Flash, its maximum number of cycles to be written is decreased, and there are only so many cycles. So what to do? If I want to do more stuff, then I need to know which pins are which, and in an earlier stage I already found that using VN or VP or D0, D1, D2, D3 cannot be used. You have to use the pin number. So after some searching on the internet, I found that this is actually GPIO 36, 39, 6, 7, 10, 11. So when I want to use LDR, the light dependent resistor, for input, I need to use 36 as an input. So let's do a final thing and see if I can actually read from the LDR using 36. Is that going to be easy? Not quite sure. It is connected. Yes, it is. By the way, the pulse width modulation is quite high. So if I change the time base to, well, now 100 milliseconds, it is all the time high, and that doesn't make very much sense. Anyway, time for the LDR to be read, and in order to do that I have to change stuff right up here. I have to make an input with it, and input IO 0 is 36, and then define input which is then of course input IO 0, and the rest can go for now. That one thing. And then I have to actually right, I have to do something with input as well, and not just output. So can I do something more? Well, I have to find that out. Of course I can, but the question is how exactly. Final attempt for now is reading the LDR and as I showed earlier, the LDR is connected to 36. So in here I added input IO 36, then define pin select 36 to 0, and from example from the GitHub of ESP32 IDF, I pulled this code. Hopefully it will work. If not, I know I have some things to do, but let me first interrupt this one. And all I have to do is make flash monitor. And get level is not working. That is something. This is an error. And right, too many arguments. Oh, alright. That is no problem. I will remove. So get level does exist. I just can't use CNT count. Go. And again, TPU ISR level undeclared in uh, 43. Oh, 83. Wait, 83. That's here. Oh, really? That will be undeclared. Alright. ISR handler. That is typical, because it is code that I just copied. So apparently I missed something, and that I think will be for next time, otherwise I exceed normal video type. So this is for next time. Nice cliffhanger, so to speak. Anyway, I still have to find out if there is any way to make to random access memory instead make to flash. I prefer random access memory. But we'll see whatever happens. But I'm happy that this works. And that's, like I said, it for now. Got this working, this not so much, while everything is connected. So whatever, here's a wire out, but makes no change. Anyway, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. Please show support by making a donation via either PayPal or Wired. And you can also choose to become a patron, and depending on the pledge, may have your name mentioned on my website and videos. More information under this video. For now, well, to be continued. Have a nice day, and bye bye.